ever-changing marketplace where construction entities are either competing or cooperating, the chance to achieve a higher gain boosts up once the players in the market understand the rules. Game theory, as a recognized mathematical set of principles, evaluates the competition and cooperation between intelligent, rational decision makers. Competitive, aka non-cooperative game theory, as one of the main branches of the game theory, studies the likelihood of the outcomes and behaviors of the decision makers in a set of rules based on outsmarting other players by considering their objectives, behavioral characteristics, and possible countermoves. The players in this game set are those who give priority to their own personal objectives and achievements. On the other hand, cooperative game theory, as the foundation to most of the unicorns in the marketplace, deals with the interaction of players who has the public benefits as their objective. It provides valuable insight for the adoption of various strategies in order to utilize the resource sharing and also lays a fair foundation so that players could benefit from the outcome. In this research, we have asked a couple of industry partners to score the importance of four major departments in a construction company. The principles of cooperative game theory then had been imposed on the data collected. As an introduction, game theory is being considered as a useful strategic framework to pinpoint various aspects of construction projects, as opposed to competitive game theory, where market players tend to outsmart each other. The cooperative game theory aims to form a coalition where the primary unit of decision making performs a collaborative behavior. The cooperative game theory focuses on the resulting collective payoffs by considering the value that each department contributes to the organization. Cooperative game theory enables the investigation of joint resource management through alliancing in construction projects. On this foundation, an individual department can identify the possible coalition that can be formed in order to increase the mutual benefits and also decide on how to distribute the generated wealth fairly and efficiently amongst the members. In the mathematical terms, if N represents the grand coalition that contains all of the role makers, in this case the departments, subset S represents a possible permutation of alliances formed by the individuals in departments. V is a characteristics function that assigns the value or worth V to each possible coalition. In an n-player cooperative game theory, the allocation of x1 to xn is a fair and efficient way of distributing the generated wealth resulted from the coalition amongst the players. In other words, xi is the player i's payoff. A cooperative strategic solution is based on this set of axioms. Equation 1 basically indicates that a set of rational decision makers in an organization will form a coalition where the sum of individual payoffs adds up to the value of the grand coalition. Equation 2 requires that the payoff for any individual would be greater than what they have initially invested. And that makes sense because nobody is going to invest in something that will cause a loss or damage to their invested asset. So equation 3 at the end indicates that the sum of cooperative allocations to any coalition S to be greater than the total obtainable gains under any coalition that includes the same players. After the core had been formed, the challenge facing the strategic planners is the definition of fairness. Various notions of fairness had been proposed, claiming the fairness is the allocation of wealth amongst the coalitions. Nash-Harsanyi bargaining solution, nucleolus, and Shapley value. Amongst these three famous approaches, Shapley had attracted most of the attention. This study, a brief introduction to the body of four major departments, namely IT department, Human Resources department, Finance and Accounting department, and Marketing department, had been provided following their set objectives. We have interviewed a few industry and academic partners with a huge history in the construction industry, and it had been indicated the characteristics function in the cooperative game theory as a result of that interview. We actually asked about their opinion on the importance of each of those, namely four major departments, to score between 0 and 100 from their opinion. It is important to be noted that the combination of the department as a new formation of an alliance had not been evaluated for the sake of this study, and it is encouraged to be done in the next step of this research. The table that you're seeing at the moment is the average response that we received for the importance of each department from the interviewees. So about 20 interviewees had been interviewed, and these average scores are given in here. And as you can see, they believe that IT department in a modern construction entity is the most important department, followed by finance and accounting. Then after that, the human resources comes, and we can see that the construction industry does not believe that the marketing department has importance more than finance and the other three departments, because that ranked below those four departments. Now the question is, what values do we get if departments form a coalition 2 by 2, 3 by 3, and as a whole? By definition, the interest rate is the expectation of market from the turnover on the initial amount of investment. The correlation of risk and interest rate is in such a way that once the investor or the borrower identifies a high risk associated with a task, the interest rate typically rises as a consequence. For the case of this study, it can be said that once the number of sub-coalitions increases, the total risk will be divided across a greater number of players, and that makes the interest rate low. In order to outline a logical output payoff for the coalition of the four departments, a fixed interest rate had been applied to the sum of individual payoffs. According to the reports obtained from the Reserve Bank of Australia, the interest rate in the Australian market had been 1.5% constant since August 2016 until May 2019. These data that you see are the payoff matrices for the coalition of a 2 by 2 department or 3 by 3 and as a whole. Each individual values are also given as a result of the interviews. So we have combined them, multiplied them by the interest rate, that is 1.5%. We've got these values. So we are expecting that the grand coalition would generate a wealth of 325.26% given those individual payoffs. The Shapley values, or in other words, the fair portion of distribution for the wealth generated as a result of the grand coalitions, are as presented in Table 2. So, what does it all mean? We said that you're expecting the construction practitioners to invest, for example, for IT department, 87.38% from 0 to 100, let's say, and the IT department would expect to get 88.33% after that initial investment of 87.38%. So if we have a limited budget, we have to allocate or invest 87.38% of that into the IT department, and the fair expectation is to expect 88.33% of income after that initial investment. That goes to all of the different departments as well. In conclusion, the fair distribution of wealth as a result of a grand coalition of four major departments in a construction firm had been identified based on the data collected. The results show that in modern context of construction firm, the IT department plays the most important role, followed by the finance department in the second place. It is interesting, since a highly labor-intensive industry as construction had voted for the importance of human resources department in the third place. The influence of robotics in construction had been once again emphasized as a result of this study. It is recommended for the newly established large construction entities to invest and distribute the wealth in accordance with the data provided.